This is a dramatic test that's going to show the limitations of an ionization smoke detector. It's called an aquarium test. We've got a 29-gallon glass aquarium, and inside I've put some polyurethane foam. It comes from a cushion from a couch just like this one. We are also using a soldering iron. This is going to create a slow, smoky fire inside the aquarium. And then we've got your common standard ionization smoke detector. I want to press that button so you can see this is a working smoke detector. I'm going to take the detector and put it right inside the aquarium. Then I'm going to take the soldering iron and put it inside the foam, and right away you're going to start to see it's going to create some smoke. Next thing, I'm going to take the top and put it right on here, because the smoke that's coming from there is extremely toxic. And now what we're going to do is sit back and wait. And while we do that, I want to point out there's a carbon monoxide detector on the corner of this aquarium inside the tank. It's going to show you how much of that deadly gas is being created inside the aquarium while we're waiting for the ionization smoke detector to go off. Right now we are 5 minutes into the test, and you can see the aquarium is pretty much full of smoke. In fact, it's so smoky, chances are right now you can't even see me waving my hand behind here, and still the ionization smoke alarm has not gone off, even though it is surrounded by thick smoke. 8 minutes into the test right now, the aquarium is so full of smoke I can't even see the smoke detector that's in there. It's that completely surrounded by smoke, and yet it's still not going off. The sound you're hearing right now is the sound of the carbon monoxide detector warning us about how dangerous it is inside of this tank. Unfortunately, the ionization detector, we're still waiting to hear from that. It hasn't gone off yet. At this moment, 11 minutes into the test, the carbon monoxide level reads 215 parts per million, more than enough to make you feel sick, and well above the reading at which firefighters are required to put on protective breathing equipment. Inside the aquarium, the smoldering fire is about to make those levels go much higher. At 17 minutes, it's over 400 parts per million. 23 minutes into the test, we've jumped to 872. That much carbon monoxide could kill you. 25 minutes into the test, we have not heard anything from the ionization smoke alarm. But right now, the carbon monoxide has already maxed out at 999 parts per million. That's as high as our carbon monoxide detector will go. Let me show you something. This is a photoelectric smoke alarm. I'm going to slide this back to put this in and watch what happens. It went off in less than 5 seconds. 5 seconds is all it took for the photoelectric smoke alarm to go off, and yet we are still waiting for the ionization. After 30 minutes, it seems clear the ionization alarm is not going to sound, so we decide to end the test. I take the aquarium outside to take off the lid and get rid of all that toxic smoke. We can hear the photoelectric smoke alarm, but what about that brand new ionization smoke detector that did not work while it was surrounded by smoke? Once all the smoke is gone, I check it out one more time to make sure the battery inside the alarm is still working. You can hear it does have a working battery. It should be a working smoke detector, and yet 30 minutes, this didn't go off. Within 5 seconds, this did. Which one do you want in your home? If you want to see something else remarkable, take a look at this. We put a few pieces of bread in a toaster, and nearby we put that exact same smoke detector from the aquarium. The smoke alarm went off in 2 minutes from simply making toast. And a lot of families have a smoke detector that does the same thing. Why will it sound quickly while you're cooking or making toast and not go off when it's surrounded by deadly levels of smoke? Here's the answer. Ionization smoke detectors respond to tiny particles, the kind of small particles that come from a very hot, fast-burning, flaming fire, or in this case, from cooking food. But a slow, smoldering, smoky fire does not produce tiny particles. It creates very large particles. photoelectric smoke alarms are able to recognize those big smoke particles